Section 1.6 is about solving compound and absolute value inequalities. A compound inequality is when you have two inequalities that are joined with the word and the word or, and we'll look at each one of those cases separately. Here you see the key concept for the word and. It's when you take an inequality like this and you put them together using the word and, which means we want all the values that are greater than or equal to -1, and at the same time all the values that are less than 2. Now, the way you do that is you graph the first one, as you see here, and you graph the second one, and you look for where they intersect, the intersection. Intersection is another word for where they cross, where they overlap. And if you can find an area where the two graphs overlap each other, that area is considered the intersection of these two inequalities. And that is the graph that is your solution. And one of the ways to do this is to make 3 graphs with the third one being your final answer. Notice the open circle here on the last one is because the intersection means you only want to take a part that's in common. Since 2 is graphed here in this top graph but not graphed in the bottom, then we don't graph it in the third one. Here 1 is graphed in the top and 1 is also graphed in the bottom, so when we intersect them, that becomes part of my solution. So compound inequalities with and, you're looking to graph the intersection. Here's an example of a compound inequality. It uses the word and the reason I know is because and is the only one that you can use by combining two inequalities together without using any words. So the way that you'll rewrite this, you'll say 13 is less than 2x plus 7 and 2x plus 7 is less than or equal to 17. That's the other way that you can write this. And again, and inequalities are the only ones that can be done that way, where you have two inequalities with a expression in the middle. And the key is you write that expression in the middle 2 times. Now we're going to solve this. I'm going to write my final solution with the letter on the left because that helps when I graph it. And then I'll solve this one over here. So we end up with an inequality, an and inequality with greater than 3 and less than or equal to 5. So let's see how we graph this. We'll start with greater than 3. That's an open circle on 3 with a shading to the right. Then we'll do less than or equal to 5. That's a closed circle on 5 because of the less than or equal to. And then we'll do our solution graph, which is a combination of the two. Now, if we want the spots where these two graphs overlap, it's going to be here at 3 with an open circle because they don't overlap on 3. This graph does not include 3 and this one does. But 5 will be included because both graphs have 5 shaded in, and the intersection says you want to take it if it's in common. So this is what the graph looks like, and then I want to show you how to write this solution out in a more concise manner. What you do is you say 3 is less than x, which is less than or equal to 5. That's how you're going to write the solution. You say x is the shaded area, it's between 3 and 5 with less than symbols, and this one is an equal to because of the closed circle. Here's our key concept for the compound inequality using the word or. We would say something like x is less than or equal to 1 or x is greater than 4, which means any number in either of those two spots will be a solution for us. Again, we graph the first one, looks like this. Graph the second one, looks like this. But this time we're not looking for the intersection. We don't care where they cross. What we want is the union. And the word union means you want to take what's in both of them. You want to take any part that is graphed. These are just different ways to say the union. So anything that's graphed will be included in our final graph. It's as if you take the two graphs and you put them together and you take anything at all, and that's what the union is. And that's how you graph or inequalities. So here's an example of an or, and notice you can't write this by using a single set of inequalities like the and. You have to use the word or. So I'm going to rewrite it. And now we'll solve each one separately. So now we want to graph all the values that are bigger than -1 or less than or equal to -7. So we'll do 3 graphs. First one for greater than or greater than -1, open circle on -1, shading to the right. And now we'll do less than or equal to -7. And then our third graph will be a combination of the two. Remember, we're not looking for an intersection. We're just going to take anything that you see graphed and we're going to put it in our last one here. We're going to combine the two. Maybe that's another word I should have used on the last slide, combine. So this is what the solution of this compound inequality looks like, and there is no special way to write it. It's just going to look like this using the word or. So now we're going to examine absolute value inequalities. We'll start by saying the absolute value of A is smaller than 4. Remember, this means the distance is less than 4. The distance from 0, in this case, is smaller than 4. Now, the reason I'm going to write this is because I want you to see what this is actually saying. If you look, any number from here to here, anything inside of there, has a distance that is smaller than 4 units away. That's what this blue area would represent. And that's what's happening when we say an absolute value. So I want you to understand that this kind of graph looks like an AND graph, typically an AND graph. And that's the case. Whenever you have a less than absolute value, you're going to create an AND inequality. So I'm going to show you how to solve this. We're going to go over here and we're going to take the letter A, and we're going to remove the absolute value signs. And we're going to say that that distance is less than 4. And we're also going to say that negative A is going to have a distance that's less than 4. Because whether you go to the right or to the left, the distance is still going to be less than 4. Whether the A is positive or negative, it doesn't matter. Now that's important because we're about to set up absolute values in a little bit using this philosophy. Now we'll look down here and we'll say that absolute values have a distance again, except this time the distance is greater than 4. So if I look at a graph again, this time I'm talking about all the values that are bigger than 4 units away, either in the positive direction or the negative direction. Now that kind of a graph typically looks like an OR graph, and that means that greater than with an absolute value means you're going to use an OR. So less than, you'll create an AND absolute value. Greater than, you'll create an OR absolute value. So let's finish this work down here. We're going to say the distance is greater than 4 units, or the negative distance is greater than 4 units, because it doesn't matter whether you're positive 4, the distance is bigger, or negative 4, the distance is still going to be bigger. So here's how you're setting up your absolute value inequalities, and then with this idea, you can then go ahead and solve them if they have an absolute value in them. So here's an example using absolute values, and if we go back to the last slide, we remember that greater than, if you ever have a greater than symbol, you're going to create an OR absolute value. So that's what this one is. This is going to be an OR. Now how do we set it up? We're going to say 3x minus 12 is greater than or equal to 6, or the negative version of 3x minus 12 is greater than or equal to 6. What we mean is it doesn't matter whether 3x minus 12 is positive or 3x minus 12 is negative. When you take the absolute value, it's going to be greater than or equal to 6. That's how you set it up to remove the absolute value symbols, and now we'll solve. In this one, we'll distribute the negative sign. Dividing by a negative, don't forget to switch the symbol. So we're looking for an OR inequality. I can sketch 3 quick graphs. I'm looking for 6 and 2. So less than or equal to 2 looks like this. Greater than or equal to 6 looks like this. And then if you do the union of those two, they don't have to overlap. That would be intersection, but we're looking for union. So your graph will be the combination of the two. And there's what it looks like. So the key with absolute values is setting them up with an or and using the positive version of this expression and the negative version of this expression.